Hello. Today we're going to talk about two special cases regarding systems of equations, and we're solving these systems by graphing. So yesterday we talked about, or even today we talked about how to find the intersection, the intersecting point of two lines, and that was our solution. And then this is two special occasions when it comes to solving systems of equations. So let's get started. The first thing you want to do is graph both lines. So no matter how you do it, I would probably suggest to you to put them both in slope-intercept form. That usually tells us a lot about the equation, but you don't have to. So the first thing we're going to do is graph the line. We're going to graph this first one. Y equals 2x minus 4. This is in slope-intercept form. So you can see that our y-intercept is negative 4. So I'm going to plot that 1, 2, 3, 4. So that wasn't very good. There is my y-intercept. And then I'm going to use the slope, which is 2, to plot other points. So there's 1, up 2, forward 1, up 2, forward 1, and I'm going to connect those lines, those dots. All right, and I have to graph the second equation. We can use intercepts, so plugging in 0 for y to get the x-intercept, or plugging in 0 for x to get the y-intercept. That's how I'm going to do this first one. So if I want to find the x-intercept, I have to plug in 0 for y. So that eliminates the minus y, and I just have 2x equals negative 6. So if I divide both sides by 2, I get negative 3. So 1, 2, 3 for my x-intercept. And then if I plug in 0 for x, I then just have negative y equals negative 6. And if negative y equals negative 6, then positive y equals 6. 1, 2, 3, 4, 5, 6. Put a dot and connect your dots. Now, what I want you to look at is the slope of this line. Okay, we know because this first line I graphed had a slope of 2 because it was in slope-intercept form, so the equation told us that. Okay, this one it wasn't quite as obvious, so I'm going to look at my graph, and you can see that this one also has a slope of 2, so up 2, forward 1. These lines are in fact parallel. And when they're parallel, they obviously don't intersect, and so there is no solution. Okay, that is the first special case. Okay, another way to check if a number is in standard form, if an equation's in standard form for the slope is to do negative a over b, and negative a is negative 2. And b is negative 1, so negative y, that actually means a coefficient of 1. And negative 2 divided by negative 1 is 2, and so I can see right away that they have the same slope. All right, same slope, lines are parallel, no solution. Let's take a look at the next slide. So here's our next special case. We have 2x minus 4, same line as we started with the last time, and now we have 2x minus y equals 4. So we're going to graph both of these in whatever method you choose. I'm going to plot the negative 4, 1, 2, 3, 4. Use the slope of 2 to get those points again. Up 2, forward 1, and connect my dots. And then I'm going to use the intercepts again for this problem. In fact, no, I'm going to solve this one for y. So you can see y equal, adding y, plus y, and that gives me 2x equals y plus 4. I'm going to subtract 4 from both sides, and I get 2x minus 4 equals y. And if that doesn't set off an alarm bell in your head, hopefully you see it. It is the same line. All right, so I would again, you could plot it, or hopefully you see right away. And I'm going to graph that same line. You can see that they overlap an infinite number of times. So we see right away it's the same line, and that means it has an infinite number of solutions. So two special cases: same line, infinite number of solutions, and if those lines happen to be parallel, there is no solution. I hope this helps, and I will see you guys next time.